Section 3.2, Example 6. In Example 6, we're going to be graphing f of x equals 3 to the x power and g of x equals log base 3 of x in the same rectangular coordinate system. So first, we shall set up a table of coordinates for f of x equals 3 to the x, and then we're going to reverse those coordinates for the inverse function, g of x equals log base 3 of x. Wait a second. Did I just say inverse function? Are we sure? Let's take a minute to check. Okay, so f of x equals 3 raised to the x power. Just to make it easier maybe for you to understand, I'm going to switch out the f of x with a y. Y equals 3 raised to the x power. Okay, now let's write that in log form. It's currently in exponential form. That would be log base 3 of y equals x. Okay, but on the last slide I said something about g of x equals log base 3 of x being the inverse function. Well, how do we write the inverse function of this? Log base 3 of y equals x. Well, first you switch the x and y's, and then you'll solve for y. So first, switching the x and the y, I'll have log base 3 of x equals y. Well, then I solve for y. It's already solved for y. So this is the inverse function of this. And log base 3 of x equals y is really the same thing as g of x, which you could change that and put a y equals log base 3 of x. So they actually are inverses of each other. Okay, so for f of x equals 3 raised to the x power, we're going to select x values of -2, -1, 0, and 1, and that should be enough to get an idea of the shape of the graph. So first we've got 3 raised to the -2nd power. That's the same as 1 over 3 to the 2nd power, which is 9. So when x is -2, y is 1/9. Next we'll have 3 raised to the -1st power. That's the same as 1 over 3 to the 1st power, which is 1/3. And then we have 3 raised to the 0 power, which is 1. And finally 3 to the 1st power, which is 3. Now earlier we said to graph g of x equals log base 3 of x, since it really is the inverse of f of x equals 3 to the x, we said we would just switch the x and y coordinates. That is another way to tell whether functions are inverses of each other. Are their x and y coordinates reversed? So we'll have 1/2 -2. We'll have 1/3 -1, we'll have 1 0, and we'll have, and actually in this table, that shouldn't be a 0, that should be a 3. And so then we'll have a 1 for its y coordinate. And so you will just graph these two in the same coordinate plane. And you should end up with something that looks a little like this. Another way to sort of check to make sure these are inverses of each other, remember a function and its inverse will be reflected across the line y equals x, which is about right here. Okay, so that's just another way to make a quick visual check to see that g of x equals log base 3 of x is really the inverse of f of x equals 3 raised to the x power.